on your last test, you need to come to my ACT lab. You need to see me before and after school. We need to get that content sorted out because you're going to be doing the exact same thing this entire unit starting next week, okay? This unit is quadratics. I'll talk about what that means in a second. But essentially everything we did last unit we're going to keep doing, but we're going to have an equation. We're going to set all those things equal to 0. We're going to factor them, and we're going to use those factors to solve for x. So instead of just factoring, we're actually solving for x when it's equal to 0. So everything that you learned last chapter, you got to still know. So these first two are factoring. We're going to do the first one together. The second one we'll do individually. So first step to factoring anything. What am I looking for? GCF. Do I have a GCF in this case? No. So I need two numbers that multiply to what? $48. How did I get 48? Yeah, A times C, 12 times 4. And add to negative 19. Any thoughts? 2 and 24 doesn't work. So we would go up more. 3 times what is 48? What's 48 divided by 3? 16. 3 and 16. Looks like it will add to 19. Which one or both are negative? Both. Okay. Boom. Then I look. Since A is not 1, it's 4. I can't just use these numbers as my factors and get going. I have to rewrite my middle term. So I'm going to write 4x squared. And instead of writing minus 19x, I'm going to write minus 16x minus 3x. And then still my plus 12. And now I took my trinomial and I made it into 4 terms. With 4 terms, what should I do? What method? Group. Group my first 2, group my last 2, put a plus sign in between if I need to. Out of the first group, what's my GCF? 4x, perfect. And I would be left with x minus 4. Yeah, what's up?
If I put the 3x in the left one, how would I do it?
You would just take out an x, but your parentheses would still match and they'd still be the same. Out of the next one, what should I take out to be left with x minus 4? What's my GCF out of here? Negative 3. So Ava, if you put the 4x squared and the 3x together, this would be your matching parentheses, the 4x minus 3. It would just be swapped. And then the x minus 4 would be the GCFs that you pull out. And then my last step, I'm just combining these factors into my answer. So x minus 4, that's my matching parentheses. We write it once. And then 4x minus 3 is those GCFs that I took out. That's my other factor. Questions on that method? Okay, I want you guys to show me you know how to do it by doing number 2 on your own or with the people around you. I will check your answer if you would like because I'm going to call on random people to walk me through this problem. So if you want me to check your answer before I randomly call on people, raise your hand and I'll check it so we don't have anxiety.
What if I do 21 minus 1?
And that would be positive. So you get a 5. If you don't analyze. Oh, sorry. You turned a positive x into a negative 4x right there. That should be a plus. So now you should be able to rock and roll. This will change to a plus. Now if you take out a negative 7. What's 6 divided by 3? 6 divided by 3? 2, there should be 2x here, and there should be 2x here. 4 divided by 2. Only 3. Put your signs here. 21 minus 4 would be positive 17. So that's just gonna switch those signs out there.
All right, let's do these as a class.
No, she's good.
She's good. And she stopped by and told me that she was going to be there. Oh, really? She told me this morning that I'm not going to be there. So she lied to you. Okay. 3 terms. First step, GCF. Taylor, do I have a GCF? No. Okay. Next step, Taylor, what'd you do? What method? X method. You need 2 numbers that multiply to what? What goes on top? And add to? Perfect. And Jude, what 2 numbers did you get?
Oh, I got 4 and -21.
Perfect. 4 and -21. Lily, where would you put those numbers? What do I do with these? Perfect. We rewrite our -17x as -21x plus 4x. Doesn't matter which way you go. You'll get the same answer. Doesn't matter what order you put those in. Seamus isn't here. Usab, what's your next step? We have 4 terms. What do we do? Regroup, okay? What's the GCF out of my first group? 2 and what? Yeah, 2x. I'm left with 3x plus 2. Nimra, what's the GCF out of my second group? -7. I'm left with 3x plus 2. And then my final answer, Brooke Woods, what do we get?
3x plus 2, 2x minus 7.
Perfect. The 3x plus 2 is our matching parentheses. It stays. And then we take the GCFs that we pulled out at the beginning. Beautiful. You will have to continue to do this all units starting next week. Today, though, is graphing. So we're not solving anything yet, but we're going to graph something called a quadratic function. A quadratic function is a function that can be written in the standard form, which we talked about a little bit with polynomials. Standard form, ax squared plus bx plus c. Standard form being your exponents decrease. And quadratic means that your degree is 2. So that means the highest exponent on x that I see is 2. Everything we look at this entire unit is going to be something x squared. Plus maybe a linear term and maybe a constant. When we graph these, their graph is not a straight line. It's like a U shape. Or an upside down U, if we flip it. We call this shape a parabola. So if I say parabola, you're thinking U shape. me 1 second. Okay. Don't get this U shape mixed up with the V shape for absolute value. If you draw a V, this unit, instead of a U, I will take off points. These, like each side of your U, it's not a straight line. So if you give me straight lines, you're going to get points taken off.
What was the V again?
The V was absolute value, so I'll talk about it in a second. You'll see the similarities. But just make sure when you're drawing these things, we connect it with like a nice little curve. If it's a straight line, you will get points off. Okay. So that's what we're doing all unit. We're dealing with some x squared things, and then today we're going to graph them. Tomorrow we'll graph them. And then starting next week, we'll talk about solving a little bit. First thing is we need to graph the most basic form of this function ever. If this was the most basic form of this, what would A be if I want something very simple?
1.
What?
1.
Yeah, 1. Can't be 0 because I need at least x squared. So A has to be 1, but do I need this other junk on the end? No. So my most basic form of this function is y equals x squared. We call that the parent function. Every other function that has an x squared is this graph, but it's flipped or stretched or shrunk or shifted left, right, up, down, but it all looks like this. To graph this and to graph all of these, you're going to need a table nearly every time, or at least today until I give you the trick tomorrow. So for our table, I'm going to pick 7 points, and I'm going to just center them around the origin. You'll see why I'm doing this in a second, but I'm just going to pick the points -3 to 3. And I'm going to plug them in. What is -3 squared? If I plug -3 in, I'm squaring the negative included,
9.
positive 9. What's -2 squared? Positive 4. What's -1 squared? 1. What's 0 squared? 0. What's 1 squared? 1. What's 2 squared? 4. 3 squared, 9. Okay. I'm going to plot these points. 0, 0 right there. -1, 1. 1, 1. -2, 4. 2, 4. And then 3, 9 falls off your graph. So these 5 points show me my U shape. I'm going to connect them with a curve. I am terrible at drawing parabolas, especially on the iPad. I don't expect you to be perfect either. If it looks as good as mine or a little bit worse, that's fine.
Where did you start drawing the line?
Where?
Yeah, my line.
Because we're graphing. So when we graph, we connect points to make a line. So I just started up here and I made a U shape.
No, that's not.
What are you asking? We are graphing right now this function to get the basic form so we can look at some characteristics before we look into more complicated stuff. Does that answer your question? Are you sure? Okay. Okay, so this is your graph for the most basic quadratic function you'll ever see. One thing to notice, if I crossed out this 0, 0 here, aka I crossed out the point where our graph changes direction. Does anyone remember what this is called? We'll talk about it later. But if I cross this out, what do we notice about these top 3 and these bottom 3? They're the same, meaning these 2 have the same y coordinate. These 2 have the same y coordinate. These 2 have the same y coordinate. So whenever I graph these, I really only need to find half of my points, and then I just copy it on the other side to get my other half, okay? So I didn't really have to plug in all of these, I just copied it over. Anyway, turn it in. Here's our parent function. We only really need to find half of our graph, this half. Once we have this half, we copy it on the other side. This point, kind of where we're copying over, is what we call the vertex. It's the point where our graph changes direction. That should sound familiar from when we did absolute values. The point where the graph changes direction is the vertex. So up here, what's my vertex? What's that point? 0, 0. So for your parent function, 0, 0 is your vertex. Something else, another characteristic that we have is something called the axis of symmetry. Does anyone remember from geometry what symmetry is? Yeah, it's essentially, it's the same on both sides. It's a mirror image of each other. We can reflect it, we can fold it over, and it looks the same. In this case, yes, very good. It is the y-axis. If I draw like a dotted line right here, and I folded my graph over that line, it's going to look the same. We call this the axis of symmetry. It is the vertical line that our graph has symmetry around. And since it's a vertical line, what is that graph like equation going to look like? Hoi vux, which one? If it's vertical. Vux. So I'm going to have x equals a number. So anytime you are writing an axis of symmetry, it should always be x equals a number. In addition, if you look, our axis of symmetry here, like Brooke said, was the y-axis. That's x equals 0. If you notice, the x-coordinate of your vertex matches whatever x is equal to in your axis of symmetry. It matches. So you don't even really have to look for it. You just pick the x-coordinate of your vertex, because that axis of symmetry always has to go through there. Second thing, you do have to graph your axis of symmetry every time. It will get annoying. You will probably forget. I forgot when I was doing some of the notes. Just be aware, you have to graph it every time. Something else that we can talk about with any graph is the y-intercept. What's my y-intercept here? 0, 0. That one we could have done without knowing anything about quadratics. Give me just 1 second. Okay. Next thing, and it's kind of hard to see on our parent graph, but there are 4 words in this unit that all mean the same thing. And those words are 0, x-intercept, solution, and root. If it says find the zeros, or find the solution, or find the root, or find the x-intercept, it's all asking for the same thing. It's asking the point where your graph touches the x-axis. So in this case, what's my x-intercept or my 0? Where does it touch the x-axis? Yeah, 0, 0. So this point is actually my x-intercept also. And today, we're going to mainly refer to them as x-intercepts. Next week, when we start solving, that's typically when we use the other 3 words. For x-intercept, we also typically put it in as an ordered pair. And for the other 3, we might have like x equals a number because we solved an equation.
At the second bullet point, why is it always x equals a number and never y?
Because it's always a vertical line. Because our graph is always that U shape, so we got to cut it down the middle.
So it's never like mirrored at the...
No, it never looks like this. Those are square root functions. We'll talk about that eventually.
So is the vertex and the x and y intercept the same?
For the parent function, yes. For every function, not necessarily. Okay, it'll change. So yeah, in this case, our x-intercept was 0, 0, or we could say x equals 0 is a solution or a root or a 0 of our function. I will tell you these 4 words mean the same thing every day. Because I promise you on the test, it's going to say find the root, and you're going to get confused because you're used to it saying find the 0 or solve. So just be aware, all 4 of these words mean the exact same thing. Last thing we can talk about, just like with any graph, domain and range. Domain is the set of all possible x values. Range is the set of all possible y values. Don't flip your page yet. Let's look at domain and range up here. domain x values. So I'm going to start at the far left. Do I have points way over here? Yeah, it almost looks like you don't, but this arrow is pointing up and to the left. So it'll take a while, and it might be like way, way up there, but I have points over here. Do I have points all the way through to infinity?
Yeah.
Yeah, so your domain is all real numbers or negative infinity to infinity. And that will always happen. It's always all real numbers for any parabola. Your range is what's going to change. Your range, if we look at this graph, do I have points down here?
No.
No. When do my points start?
0.
0. Is 0 included or excluded? Included. So we include it, 0. And am I good all the way through to infinity? Yeah. Infinity. Your range is going to change, but something to notice about the range, it's kind of weird to see because our vertex is 0, 0, but this end point of your range actually comes from the y-coordinate of your vertex. So it might switch. This might be 2, or it might be negative infinity to 2 if your graph is upside down, but it always comes from the y-coordinate of your vertex. Questions on any of those definitions? Because we're going to use them the rest of the time. Okay. Let's find these characteristics for this graph. It says vertex. We're looking for the point where the graph changes direction. Where would that point be? Perfect. Right here, negative 2, 4. You're looking for the peak of your u. Negative 2, 4. Axis of symmetry, x equals a number. What number from our vertex does x equal? Negative 2. It should always be the x-coordinate of your vertex because it has to go through that point. So I drew it in. Something else that bothers me about this graph is I'm going to draw some arrows on it. Don't forget we need arrows on both ends. Zeros, x-intercept solutions, and roots. Where does my graph hit the x-axis?
0.
Okay, yeah, 0 and negative 4. Right here, boom, it's hitting the x-axis. And right here, it's hitting the x-axis. So those points are negative 4, 0, and 0, 0. So if it's asking for the x-intercept, that's probably the way that I'll put it. But when we talk next week about zeros, solutions, and roots, you're probably going to see it as x equals negative 4 or x equals 0. So just be aware, if you're solving things, you probably have x equals a number. But if you are graphing things, you probably write those as an ordered pair. Okay? Last thing for this graph, domain is always what?
X values.
Yeah, real numbers, it's the possible x values. It never changes for quadratics. It's always all real numbers. Range, very close. We know for a fact that 4 is going to be one of my endpoints because it's the y-coordinate of my vertex. If I start down here at negative infinity, do I have points down here?
Yeah.
Negative infinity, and they stop where?
4.
At 4. So just be careful when it's upside down, your infinities come first. So this one is negative infinity to 4 with a bracket around 4. Very similar to our other range. We just kind of flipped it because it was going the opposite direction. Questions on vertex, axis of symmetry, domain, range, zeros?
Are the numbers always going to be included?
Yes, for your range, yes, because you'll always have your actual vertex at that number.
Okay.
Great question. So yeah, it will always be parenthesis bracket or bracket parenthesis. Okay? Any other questions? Okay. 2 more definitions. These ones are pretty straightforward. The wording is just a little weird. If a question asks you for the maximum point, notice I bolded the word point because the next definition is nearly identical. Maximum point is the actual ordered pair where your graph is at the highest or lowest in the entire graph. So here, this is the same example we just did. What's my maximum point?
4.
4. Well, point. Here's my point. What's that ordered pair? -2, 4. So again, our graph is upside down. Our highest point, our maximum, was -2, 4. Over here, our graph is right side up. Are we going to have a minimum, a low point, or a maximum, a high point? Minimum, okay. What's my minimum point right here? -1, -4. What is the same about our minimum and maximum point versus one of these things up here? What is our minimum and maximum point? Always.
X and Y.
It's always X and Y, but what point on here is it? Is it our zeros? Is it our y-intercept? It's what? I heard it. Yeah, it's always our vertex. So the maximum or minimum point is your vertex. Always. You just have to determine if it's maximum or minimum based on if your graph is up or down. Okay? The wording gets a little weird because it also might ask you for a maximum or minimum value. If it says value, or like what is the maximum or minimum, this is when you just look at the y-coordinate of your vertex. We care about how high or how low did the graph go. We don't care when that happened. We just care about what is its actual maximum. Well, this one hits 4, and this one, its lowest point is -4. So it's just the y-coordinate, 4 and -4. Just be aware you will get those kind of words mixed up a little bit. Questions on those definitions before we get to graphing? Okay. We're going to do this kind of backwards. The normal standard form, we're not going to talk about this until tomorrow. We're going to talk about two kind of easier forms to graph first. First one is vertex form. If you remember, we had vertex form for absolute values as well, and they looked nearly identical. For absolute value, our vertex form was y equals a times absolute value, x minus h plus k. They are nearly identical. This one we took the absolute value, this one we're squaring. That's the only difference. The graphs obviously look different, but most of these characteristics we can fill out the same way that we did for our absolute value. So I would put a star next to this box, circle it, highlight it, do something because you'll be referring to it quite often. This is just one of those things that you'll have to memorize for the test, is all of these characteristics from your graph. Luckily, they're nearly the same as absolute value. Your vertex is at HK. Be aware, H is an opposite sign. So if it is x minus a number, that number is really positive. Okay, opposite sign. Your maximum or minimum was the y value of your vertex, so k. Your axis of symmetry is the x coordinate of your vertex, so h. Those are all given to you just if you look at the equation. The rest kind of comes from graphing. A, this coefficient out front, determines our steepness. For absolute value, it determined the slope of the right-hand side. Well, now we have a curve, so it doesn't really determine the slope. It kind of helps with something else that I won't talk about until tomorrow. But for now, all you need to know is, let's compare the dark blue to the yellow. Which one of those is narrower, meaning skinnier? The yellow. So it's going to be narrower if our A value is greater than 1. Or, to include negatives, let's make the absolute value of A greater than 1. Meaning it's a whole number, it's a fraction bigger than 1. That's when we're going to vertically stretch. We're going to vertically shrink when A is less than 1, like in this 1/2 situation. It's wider. We compressed it. It's going to be the same if A equals 1, meaning the same as your parent graph. And then again, this was fraction less than 1. So like 1/2 would be wider, but 3/2, because that's greater than 1, is going to be narrower. Same vibe as absolute value. Also, same vibe as absolute value is when we flip our graph over the x-axis or not. If we look at green and blue, those are the same graph, just flipped. How do those equations compare? What changed? We have a negative sign out front. So it's going to open up if A is positive, if it's greater than 0. That's like our yellow one. A was 1. Or not our yellow, sorry, our blue and our yellow. It's going to open down if A is less than 0, if A is negative. If A equals 0, then we don't have a quadratic, so we don't even have to worry about it. So again, this is just like one of those 5 bullet points that you have to be able to know just being given an equation. Some questions are going to ask you for x-intercepts. For now, we're going to estimate x-intercepts if they are a decimal. Meaning, if they don't come nicely out of your table with whole numbers, we're just going to estimate them, or we're just going to write decimal next to x-intercept. On your homework, it shouldn't have any of those. It doesn't have any of those, but we won't actually talk about how to find x-intercepts until next week when we start solving. So just be aware, if the x-intercept is not straight from a table or straight from plugging in values, just hang tight on it. It's probably a fraction, and we'll deal with it next week. Questions on those properties? Okay, now we're going to graph some. I'm going to kind of hop back and forth between like these steps and this example because we're going to kind of do the steps as we do the example. So, first step to graphing in vertex form is identify A, H, and K. So if we look down here at example 1, what would A be? 3. Good. Be careful here. What's H? Positive 4. We switch the sign. What is K? Negative 3. We keep the sign. Okay. From there, we know a good amount of stuff for our graph. Step 2 says plot the vertex and draw the axis of symmetry. If H is 4 and K is negative 3, what's my vertex? 4, negative 3. It's just HK. So I take H, I take K, and I put them in as an ordered pair. Thank you. If my vertex is 4, negative 3, what's my axis of symmetry? X equals... Yeah, X has to equal 4. That's my X coordinate of my vertex. So X equals 4. That comes straight from my vertex. I'm going to pause there. I'm done with step 2 once I graph. So I'm going to graph these points and my axis of symmetry. Step 3. Once you find the vertex, the rest kind of just falls into place. You plug and chug on 1/2 of your axis of symmetry, and you copy it, you reflect it over on the other side. So we're going to pick 2 points on the right side of our axis of symmetry, and we're going to reflect them to the left. In total, in order for your graph to be done, you need 5 points. This includes your vertex and 2 points on each side, and you need your axis of symmetry. I'm going to abbreviate it AOS. So your graph is not done until you have all 6 of those things. So I'm going to draw my table. I'm going to put my vertex in. And again, I like to put like a little line through here so I know that that's the line I'm reflecting over. I know that all my y values over here are going to be the same over here. And then I'm just going to pick points close to my vertex. So if I start at 4, what would be my next point? 5 and then 6. So I'm going to try 5 and try 6. If I go the other way, 3 and 2. So these are the points that I'm going to test.
Can you turn it around too? Like put the 5 and 6 over the 4 and the 2 and 3 under.
You
So it's
can.
kinda like a graph. So it's kind of like the,
You can, but this is kind of like the graph to me because it goes from smallest to biggest and it goes from smallest to biggest. So I would keep them in numerical order, especially for parabolas, because that's how we reflect them across. Like these two, this 2 and the 6 kind of have to go together. So I would try to keep them in numerical order. But let's just plug in half of my points, probably this half, these look easier, and then I'm going to copy them over here. So let's plug in 2. All I'm doing is replacing my x with 2. So 3 times 2 minus 4 squared minus 3. 2 minus 4 is negative 2. Negative 2 squared,
4.
4. So this is 3 times 4 minus 3. 3 times 4 is 12. Minus 3 is 9. So I have a point at 2, 9. And if I have a point at 2, 9, what other point do I have? 6, 9. They're the same. Same y value. The only reason that works is because their x coordinates are the same distance away from the vertex. 4 minus 2 got us to 2, and 4 plus 2 got us to 6. So that has to be true as well. Has to be symmetrical. So we graph 2, 9. There's 2, 9. There's 6, 9. I'm almost done. I only need 2 more points, so really 1 more point. Next thing I'm going to try is 3. I'm going to plug 3 in and solve for y. 3 minus 4?
Negative 1.
Negative 1 squared?
1.
1. So this would be 3 times 1 minus 3, which gives us
0.
0. So I have the point 3, 0. What other point do I have?
5, 0.
5, 0. Perfect. Graph them. Here's 3, 0. Here's 5, 0. I'm essentially done. I just have to connect them now with a parabola. The narrower your graphs get, the harder it is for that U shape. So just try your best to make it look like a curve. I don't want any straight lines. So like in this case, I would say I do have x-intercepts. They're 3, 0, and 5, 0, and they came straight from my graph. I wouldn't have to estimate them. I wouldn't have to say decimal. They just come straight from my table. Okay? And all of the ones on your homework will come straight from your table. Questions on that one? Okay. Since all of this entire method, process, whatever, starts with the vertex, we have to make sure our vertex is correct, because if it's not, everything else is going to be messed up. So we're going to run through 6 of these problems that are in vertex form, and we're just going to write down H, K, and the vertex. So again, we're looking for H and K. For number 1, what is H? 4. You have to switch the sign. What's K? Negative 5. So my vertex is 4, negative 5. This might sound tedious and like annoying, but I promise someone will mess up some signs on a test. So we're going to practice it. This one's a little trickier. I don't have parentheses. If I wanted to rewrite this as x minus a number squared minus 8, just so I can get my H value, what number has to go in here? Not 1, 0. X minus 0 is 0, or x. These are the same, x minus 0 and x. So now, what's H? 0. What's K? Negative 8. So my vertex is 0, negative 8. Other one's kind of similar. I have something in the parentheses, but I need something on the outside here. What am I really adding on the outside? What number? 0. Okay, so H is what? Negative 1. We flip the sign there. And K is What I add on to the end? 0. So my vertex, -1, 0. I want you guys to do these bottom 3, find the vertex. Once you're done with that, I also want you to find the vertex of the next graphing one on page 5. Okay, so find these vertices, and I want you to find the vertex of this one. Then we'll graph it together. Natalie, what'd you get for your first vertex? I agree. 1, 3. You just got to flip the sign on the -1. 1, 3. Do-do-do. May, what'd you get for the second one?
I got 7.
Perfect. 7. And then this is really a +0 on the side. So 7, 0. Second one's a little bit tricky. Oliver, what'd you get for your vertex?
I got 0, 9.
Perfect. 0, 9. H is 0 in that case. Questions on those 3? Braden.
If there's like no parentheses, like how like the second and the sixth one were, is it always 0?
H is 0, yes. And if there's nothing on the end, K is 0. Yeah. Any other questions? Okay. Charlie, what'd you get for your vertex for this first one? The graphing one. Perfect. 1, 5. We're going to start there. I'm going to graph my vertex. That's step 1. There's 1, 5. My H value is 1. So what's my axis of symmetry? Yeah, x equals 1. So I'm going to draw a line, vertical line. X equals 1. And now I'm just going to start on my table. Once you have your vertex graphed and good to go, it's time for your table. So I'm just going to throw my vertex in there so I know what line I'm reflecting over. Then I'm going to pick some points, 2 on each side. If I go to the left, what's 1 unit to the left? 0 and -1. So those are the first ones that I'm going to plug in. Again, just be careful. Put these in numerical order so you can reflect it from the table. And then if I go on the right side, 2 and 3 would be my x values over there. And then I plug it in. Which looks easier to plug in, 0 or 2?
0.
I agree, 0 is probably easier. So let's plug in 0 for x. I'm just replacing x with 0 and simplifying. 0 minus 1?
0.
-1 squared,
1.
+1. Then I have to tack a negative back on, so really -1. Plus 5 gives me 4. So 0, 4 is a point. What's another point that I know? 2, 4. Perfect. We reflect it. Again, you can reflect it from the table, or we could have graphed 0, 4 and reflected it from the graph. Either way, you get those 2 points. It's up to you which way you want to do it. I typically reflect it in the table and then check it visually with my graph. Next one, what's probably going to be easier to plug in, a positive or a negative number?
Negative.
Let's do positive. Let's keep everything positive. You can plug in negative if you're feeling comfortable. But let's plug in +3. So again, just replace that x with 3 and simplify. 3 minus 1?
2.
2. 2 squared? 4. And then we make it negative. So -4 plus 5?
4.
+1. So 3, 1 is a point. What's another point?
Negative 1, 1.
Negative 1, 1. Then I graph. There's that one. There's 3, 1. I could find another point down here. I think negative 2, negative 4 would be a point. And 4, negative 4 would be a point. You could plug those in and get those. Or this is fine with just those 5. You just need enough to get that U shape and figure out how narrow or wide it is.
Do you just need 5 points?
5 points, vertex, and then 2 on each side. And your axis of symmetry. Okay? Ava.
Do we only have to draw lines until we get to the point that we got, or should we like estimate it?
You should make sure your graph fills up the whole graph, if that's what you're saying. Don't draw a little parabola like this.
Okay.
Make sure it fills up a good amount of space. And if you
Even
think
we
you're,
don't have the points.
huh?
Even if we don't have the points.
If you're drawing a lot extra where you don't have points, probably just try to find one down there so you know your shape is right.
Where'd you get the bottom 2 numbers, or the bottom 2 dots?
I could have plugged it in my head and done it. I did it a different way with a trick that I'll show you tomorrow
Do
or
we need to
Friday.
have the extra
Thursday.
dots, or do we have that?
No, in this case, I'm fine with just those top 5. I just added those extra ones so I can truly see how narrow or wide it was. So you could plug in negative 2 and 4 and get negative 4, or just leave it with those top 5 and I'll give you the trick on Thursday. Okay? Okay, let's fill out the rest. X-intercepts. What are they? Do they look like a whole number?
Yeah.
No, it's going to cross somewhere between, in this case, 3 and 4, or negative 1 and negative 2. So it's going to be a decimal, which I don't know how to find those yet. We won't know until next week how to find those. Y-intercept. That's when x is 0. What's y when x is 0? 4. So 0, 4. My graph, does it open up or down? Down, which means do I have a maximum or a minimum? Max, this point up here is my highest point. It's maximum. What is my maximum value? 5. It's the y-coordinate of my vertex. Again, something else I could say is a max of 5 at negative 1. My max is occurring. I have a max of 5, but it's occurring at 1. Domain and range. Domain is always what? All real numbers. Negative infinity to infinity. Range. If I start down here, negative infinity. When do I stop? 5 included or excluded? Included. It's always included. Okay. So that's graphing from vertex form. It is very, very similar to absolute value. Give me a thumbs up, sideways down on how we feel about vertex form. Decent. Okay. Vertex form is really good for finding your vertex. It gives it to you right off the bat. The other form that we talk about today is going to be intercept form. What do we think intercept form is really good at finding out? The x-intercepts, yeah. So intercept form gives you the x-intercepts just from looking at it. Intercept form is a times x minus a number, x minus a number. This looks like what we did last unit. This is the factored version of standard form. So all we did was we factored our equation, and we got this. So that's when factoring is going to come into play, is when we create things in intercept form. So this one gives you your x-intercepts. Our x-intercepts, in this case, are P and Q. Just be aware, those are opposite signs. So just like with H, you have to flip the sign for P and Q. Your axis of symmetry, or the x-coordinate of your vertex, is directly in the middle of P and Q. So what you do is you find the average of P and Q, or find the middle. You take P and Q, you add them up, you divide by 2. You're finding the middle. Once you have your x coordinate, you plug it in to find y, to find the y part of your vertex. So your vertex here, you kind of have to do some work to find. It's not given to you. But you have two other points that are given to you. That's your x-intercepts. So there's kind of benefits to both. In the last section, we'll talk about when we might want to use one version versus the other and switching between the two and all of those things. A works the exact same way. Narrower if absolute value is greater than 1, so a fraction bigger than 1. Wider if it's a fraction smaller than 1. It opens up like a normal U if A is positive. And it opens down like an upside down U if A is negative. So again, I would put a star around this box, circle it, highlight it, do whatever, but you're going to want to refer to this a lot in this unit anytime you graph. And then again, for the steps, I'm kind of going to hop back and forth between these two. So I'll try to leave these steps on here so you're not flipping on your paper. But let's graph one. Step 1, identify the x-intercepts, aka let's find P and Q. In here, it doesn't really matter which one's which, but what's P? -3 or +3? +3, flip the sign. What's Q? 7. So that means right off the bat, just from P and Q, I have 2 points. What's one of them? If they're my x-intercepts. If they're my x-intercepts, what's the y value at both of those? 0. Yeah, so I have 3, 0, and 7, 0. Immediately, I have those 2 points. So 3, 0, 7, 0. Yes?
Are those the P's and Q's that we did with the...
No, different P's and Q's. In math, we run out of letters, so P and Q are kind of common letters to use.
So where do we get them from again?
It is just these two numbers right here. Just flip the sign.
So the first one's always P and the second one's always...
It doesn't matter which is which. It doesn't matter. You can call either one P and either one Q. Any other questions on those P's and Q's? Okay. Axis of symmetry is harder to find. We need to add P plus Q, and you divide it by 2, and that's our vertical line. So I'm going to do 7 plus 3 divided by 2. What do I get? 5. So my axis of symmetry is the vertical line, x equals 5. I'm going to draw it in. Double check with your graph. My line looks like it's right in the middle of my 2 points. Okay. If my axis of symmetry is x equals 5, what is the x coordinate of my vertex? 5. It has to go through that line, or that line has to go through my vertex. So my vertex is going to be somewhere on this line. I just have to find out where. And to find out where, I make a table. On your homework tonight, I'm going to post the answer key, but if you don't have a table written down, you're going to get 0 points for not showing work. All of these need to have a table, at least at this point in time. Once I show you the trick on Thursday, I'll be a little bit more lenient with that, but right now they all need to have a table. So, my vertex is 5 something. Again, I'm just going to stick a line through it so I know that that's my vertex. That part, completely optional. I just do it so I know what I'm reflecting over. Then we have to plug in 5. If I plug in 5, 5 minus 3 times 5 minus 7. 5 minus 3 is? 2. 5 minus 7? Negative 2 times 2? -4. So 5, -4 is my vertex. I already have 1 point, 1 on each side. So I just need 1 more on each side. So I'm going to start at 5. I'm going to go 1 each way. 4 and 6. I'm going to just plug one of them in because I know that they're going to have the same y coordinate. So I'm going to reflect it across that line. So let's just plug in 4 and see what we get. 4 minus 3 times 4 minus 7. 4 minus 3 is 1. 4 minus 7 is negative 3. Negative 3 times 1 is negative 3.
Why'd you do that?
Why did I do what? Right here? I just plugged 4 in. I needed to find my y coordinate for this x coordinate of 4. I just plugged 4 into my equation. And since I have 4, negative 3, what else do I have? What other
6
point?
negative 3.
6, negative 3. Again, just double check, like, these should be the same distance away from your x coordinate of your vertex. Like 5 plus 1 is 6, 5 minus 1 is 4. They should be symmetrical. So now I'm going to plot those, 4, negative 3, 6, negative 3. And now I have my U shape that I can kind of look at. If you wanted another point, give me a second, Ava. If you want another point, it would be up here at 2, 5. And at, if we reflect it over, 7, 5. You don't need those. I'm fine with just the bottom 5, but there's some more points if you want to graph them. I just did those really fast in my head. That trick that I did, I'll show you tomorrow.
Did we not do the, like, one above the 4 and below the 6, like 3 and 7 as the x, because we already got it from the P's and Q's?
Correct. Those, yeah. We didn't need to redo these because these counted as 1 point on each side. We just needed 1 more on each side. Great question. Any other questions about that one? Ooh. We connect our line with a curve. Good enough. Are you good?
Yeah.
Okay. Questions, comments, concerns?
Wait, so the vertex is 5, negative 4.
Oh, yeah. Yeah, let's fill that info out. 5, negative 4. Thank you, Jude. Right here is your vertex. Any other questions? Okay. Last one. And then you'll have time, a good chunk of time, for your homework. This one is in intercept form. First step, find P, Q, and A. What's A in this case? Negative 1. It's kind of hidden, but there's a negative 1 right there. If we just go in order, what's P? Negative 2. Flip the sign right here. What's Q? Positive 3. Okay. Right off the bat, I'm going to fill out what I know. I know my x-intercepts from P and Q. So my x-intercepts are negative 2, 0, 3, 0. Graph them. Negative 2, 0, 3, 0. I also know what direction my graph opens. A is negative 1. Is it going to open up or down? Down. Okay, if it opens down, meaning it's an upside down U, do I have a maximum or a minimum? Maximum. That's kind of all that I can fill out right now. But that's quite a bit for just looking at my equation and finding 3 numbers.
Don't we also have the axis of symmetry?
We have to find it. We have to do some math. But
Besides looking at it, can we just take the half of it?
yeah, so in a way, yeah, we could just look at our graph and kind of take half of it. But if we take half of this, we're going to get a fraction. So I'm going to double check it with my P's and Q's. So to find the axis of symmetry, P plus Q over 2, I end up getting 1/2. So x equals 1/2 is my axis of symmetry. It's going to be a little bit weird to draw, but it's like right here, in between 0 and 1. Okay, I have my axis of symmetry. What's the x coordinate of my vertex? 1/2. It's the same. So if you want to like highlight them or whatever to show that they're the same, and that's where I'm getting that from, That works. Okay, I need to find the y coordinate. The only way I can find the y coordinate is to do what?
Which people?
Yep, the table. We plug it in and we see what we get. So I'm going to set up my table. X and y. 1/2 is my vertex here. Again, I'm just going to draw a little line through it so I know it's my vertex and I know I'm reflecting over it. Okay. You might be inclined to go straight to your calculator, and that's fine. Just be careful. Make sure you plug in everything right. Make sure you don't lose any signs. Make sure everything's in parentheses. I'll show you how to do it probably just as fast in your head or like on a piece of paper. Let's plug in 1/2. I would have negative 1/2 plus 2 and 1/2 minus 3. Okay. I need to combine 1/2 and 2, which means I need to write 2 as a number divided by 2. What number divided by 2 is 2? Higher than 2.
Oh, 4.
4, yeah. 4. We're just changing the denominator. My denominator was 1. I multiplied it by 2 to get 2. So I have to multiply the top by 2 as well. Just,
You said you multiplied them.
I took 2 over 1 and I wanted to change it to something over 2. So I multiplied top and bottom by 2. I got 4 over 2. Change.
The bottom 2 would be multiplied to 2 by 2.
I multiplied 2 by 1.
Oh, okay.
Okay. For the second one, 1/2. And then for 3, same thing. Multiply top and bottom by 2. What do I end up getting? What over 2 is 3?
1/2.
6. 6 divided by 2 is 3. Multiply top and bottom. 3 over 1 by 2 over 2. We get 6 over 2. Okay. Now we deal with the fractions. 1/2 plus 4/2 is what? 5/2. Add the numerators, keep the denominator. 1/2 minus 6/2. Negative 5/2. Okay, my negatives are going to cancel. So my final answer is going to be positive. And then I multiply straight across. 5 times 5 is 25. 2 times 2 is 4. You could have put that into the calculator. That's fine. You can't show work off of your calculator unless you show me at least this step. So just be careful if you're using your calculator. Make sure you plug in everything correctly, or else the rest of everything is going to be all messed up. I don't know where 25 over 4 is on a graph. How could I kind of figure out what two numbers that's between? What if I put it into my calculator? What do I get? If I put 25 divided by 4, what do you get? 6.25, yeah, or 6 1/4. Either one works, but my vertex is now at positive 1/2 and 6 1/4, so 6 and a little bit. Okay. If I wanted to, I would move 1, so I would do negative 1/2, and I would move 1, so I would do 1 1/2. I'm done dealing with fractions. I dealt with them. I don't want to deal with them anymore. So let's pick the closest whole number on each side. What's the closest whole number to 1/2 if we go less than 1/2?
Negative.
0. 0. And then if we go the other way, 1. And then we can do it again, Ava. We would get negative 1 and 2. So this is kind of how I'm going to set this one up. I just didn't want to deal with the little fractions in here, so I'm not dealing with them. Now, we plug in. If I plug in 0 up here, 0 plus 2 is 2. 0 minus 3,
Negative
2 times negative 3,
3. Negative 6.
negative 6 times negative 1,
Negative 6.
positive 6. So positive 6. If 0, 6 is a point, what other point do I have? 1, 6. I reflect it over my line. Then I graph it. It's going to be like really close to my other point just because I only, oopsies, and my other point was wrong. Hold on. There we go. There we go. Those 3 points are going to be really close just because we dealt with a fraction, but that's all right. Technically, that satisfies my 5 points and my axis of symmetry requirement. I'm going to do one more just because this is kind of gross, and I want them a little bit more spread out between here and here. So let me pick -1 and 2. I don't want to deal with negatives, so let's handle the 2. 2 plus 2? 4. 2 minus 3? -1. 4 times -1. -4 times -1. 4. Very good. 4. So I have 2, 4. And if I reflect it, I have -1, 4. And then I graph. Connect it with a U. Again, it looks a little bit weird because my vertex is a fraction, but it'll look something like that. And then we just have to fill out the rest of the stuff. So my vertex was at 1/2 and then 6 1/4 or 6.25 or 25/4 is what I'm going to put. My y-intercept, when x is 0, what's y? 6. So my y-intercept is 0, 6. We already said I have a max. What's my maximum value? How tall, how high does my graph get?
6.25.
6.25. Or 6 1/4 or 25/4, whatever your heart desires is fine. Domain for quadratics is always all real numbers, -infinity to infinity. Range, starting at -infinity, do I have points down here? When do my points stop? 6.25, so -infinity to 6.25 included because our vertex is at that point. Okay. I am probably going to make a little poster of all of these things so it's at least in front of us nice and pretty for the whole unit because we're probably going to forget about this stuff in 4 weeks when we get tested over it. So just an FYI, this is like day 1 and it's a lot of memorization. Just try to work on memorizing it up until your chapter test, okay? Which again is on the 18th. Questions, comments, concerns? Okay, your